Let's start another long answer question of differentiation problem. It is also 7-mark question from 1B. Okay. So here the given question is, if under root of 1 minus x square plus under root of 1 minus y square is equals to a into x minus y, then show that dy by dx is equals to under root of 1 minus y square by 1 minus x square. Okay. So again here we will be starting with the substitution method. Okay. So what he has given over here, given under root of 1 minus x square plus under root of 1 minus y square is equals to a into x minus y. This is the given part. Okay. So here we will start with the substitution. Let x is equals to sine alpha. In place of x, what are we going to substitute? Sine alpha. Now if we bring the sine over here, it turns out to be sine inverse x is equals to alpha. Similarly, y is equals to sine beta, means wherever you find y you need to substitute sine beta, and if you bring here y sine, it turns out to be sine inverse y is equals to beta. Okay. Now substituting in the given part, the problem turns out to be under root of 1 minus, instead of x what are we writing? Sine alpha. So this turns out to be 1 minus sine square alpha plus under root of 1 minus sine square beta is equals to a into what is x? Sine alpha minus sine beta y. Okay. So we know that 1 minus sine square alpha, 1 minus sine square theta is equals to cos square theta. We are going to use this formula in the above. So this turns out to be under root of cos square alpha plus under root of cos square beta, which is equals to a into sine alpha minus sine beta. Okay, square and root gets cancelled. Here also square and root gets cancelled. So we are left with cos alpha plus cos beta is equals to a into sine alpha minus sine beta. Sine beta. Now again we have some formulas over here. The first formula again we are going to use is cos C plus cos D formula. What is cos C plus cos D? It is 2 cos C plus D by 2 cos C minus D by 2. Similarly, again we are going to use cos C minus cos D. Sorry, sin C minus sin D. The other formula is sin C minus sin D. Okay. What is sin C minus sin D? 2 cos C plus D by 2 sin C minus D by 2. We need to remember these formulas for solving this problem. Now if we substitute in the above equation, this turns out to be, instead of alpha and beta, here the formula, in the formula it is C and D. So we are just going to replace C and D with alpha plus alpha and beta. So this turns out to be 2 cos alpha plus beta by 2 into cos alpha minus beta by 2. Okay. LHS part is over. Similarly, in the RHS, a into, okay, this is 2 cos alpha plus beta by 2 into sine alpha minus beta by 2. Now 2 over here and here gets cancelled. Cos of alpha plus beta by 2, cos of alpha plus beta by 2. Now we are left here with cos of alpha minus beta by 2, and in the RHS a into sine of alpha minus beta by 2. Okay, now bring this sine onto the left hand side. Cos of alpha minus beta by 2 divided by sine of alpha minus beta by 2 is equals to a. Okay. Now what is cos by sine? It is cot. So this turns out to be cot of alpha minus beta by 2. Now take this cot over this side. This turns out to be cot inverse a is equals to alpha minus beta by 2. Take this 2 over there. 2 cot inverse a is equals to alpha minus beta by 2. Okay. Now in the starting only we have seen what is alpha and what is beta. See, what is alpha? It is sine inverse x minus this is sine inverse y. Where did we get this? We got from the starting part that is this one. Sine inverse x is alpha and sine inverse y is beta. So instead of alpha and beta, we are going to write sine inverse x and sine inverse y. Now we have another formula over here. Okay, now we are going to start the differentiation part right now. So differentiation with respect to x on both sides. Okay, so now this turns out to be dy dx of 2 cot inverse a, which is also equal to dy dx of sine inverse x minus dy dx of sine inverse y. Now here, because we are going to differentiate with x and here the variable here it is a, so this is constant. This turns out to be constant and differentiation of constant is 0. So we got this part as 0. And here, as we have the formula dy dx of sine inverse x is equals to 1 by under root of 1 minus x square. We are going to use this formula. So this turns out to be 1 by under root of 1 minus x square minus similarly this also, but in the variable y, 1 minus 1. Now here, as we are supposed to do the differentiation with respect to x, but we are applying it to the variable y, है ना? So into we need to write over here dy by dx. Okay, now bring this term over here onto the this side, RHS side, left hand side. So this turns out to be 1 by under root of 1 minus y square into dy by dx. Because it was minus, it turned out to be plus, is equals to 1 by under root of 1 minus x square. Now what we have to do is just to send this 1 minus y square onto the RHS, keeping dy by dx on the LHS, is equals to under root of 1 minus y square by under root of 1 minus x square. So this can be written as, in the end, dy by dx is equals to under root of 1 minus y square by 1 minus x square. We have got the solution.